Hello and welcome. My name is Jürgen Rinelli and I'm a software consultant. In my today's tutorial, I want to show you the capabilities of vulnerability management or threats and patches within Endpoint Central's module, or the same would be the Vulnerability Manager Standalone Edition. And this time I'm gonna dive a bit deeper into the theories, into where's the differences between the scores and why on one side the CVSS might be a 9.8, but the importance is in a risk factor not that high. So I hope to get that clearer in the end for you. And hopefully do not make it more worse, the confusions about all those risk assessments out there. And by the way, it might be a cool thing, this tutorial, to show you that end of life of Windows Update services is no problem at all. Have fun. All right. So let's start right away with the threats and patches. All the prerequisites and the details about Endpoint Central or the Vulnerability Manager you already know out of my previous videos. Today, I don't only want to cover the look and feel and where to go within threats and patches, I want to show you even why the end of life, let's say from WSUS, Windows Update Service, is not a problem at all. There are solutions helping you get your way around through all the vulnerability risks out there. And in order to show everything in detail, I'm gonna tell more about every risk score. So there is more talking in that, more theoretically talking in that video today as well. But first things first. Threats and patches, that's a module within Endpoint Central, the big solution from ManageEngine. And these threats and patches, you can have it as a standalone edition as well, called Vulnerability Management. This is available cloud and on-prem. So what we do have here is a dashboard. Okay, every solution out there has a dashboard. I'm gonna talk more in details about that in a minute. We have more dashboards here: security configurations, systems, and patches. But first, what can we patch? There is within the settings, the patch database settings. We are able to patch everything covered previously from WSUS. And we have a large third-party patch database, capabilities to patch third-party software. We have drivers and buyers. As well, we can patch Mac and Linux systems. Well then, let's start simple. Just starting with the patches. When there is an agent out there on the systems, all the agents will be scanned and they collect what patches are missing. And all the missing patches, you will find them here in the Missing Patches tab. Okay, what do we have here? We find the patch ID, bulletin ID. Everything is linked even to more resources, languages supported, and this is the download location. It is coming always from the respective Windows side. So there is a secure way in downloading the patches. It will be automatically downloaded when there is a configuration in place into the Endpoint Central server repositories. The bulletin ID, of course, is linked as well. Let's close that. What else do we have? We have another more information tab, the bulletin details, with more patch details. All right, then we have the patch description, of course, necessary. we need to know what we're gonna patch. The approval status, it is approved or not approved, and we have the missing systems, we have failed systems, and that's something we will cover in a minute. And we have the platform, the reboot required, not required, and the patch uninstallation, if it is supported by the patch or not. It is nothing to do with the unwillingness of patch management that it won't be possible to uninstall. That's coming from the Windows directly. Well, then there are more columns you can choose of course. Fine. Then what's about that reliability score out there? The score combines real-world deployment telemetry with internet intelligence to estimate how reliable a patch is behaving in practice. A higher score indicates more consistent observed behavior. A lower score is a signal to proceed more cautiously. For example, by using a pilot group, performing additional validation, or waiting for more deployment feedback before a broad rollout. That's an additional decision aid for patch deployment. Then there is that approval status. That approval status, if you have it at not approved, you only are able to deploy patches in the digital manual sneaker administration way. Let's say you just click on here, install publish patches, you give it a name, and the deployment policy, that's the when and the how, and this is covered in another tutorial already. You can publish all the patches to a self-service portal if you want, and even do both. Deploy it on, let's say, Friday, and all the days before Friday you are able to install it through the self-service portal, something like that. You can configure it, and here is already the client in the target, and just go on deploy and the deployment will start. Well, that's out from the missing patches if there is no improvement already. An automate rollout can only be done when you approve that patch, mark it as approved. Then the patch will be green, and green patches can be deployed in a deployment policy in an automatic way when we configure it. We will see that later. Of course, you always are able to decline patches here. And even through the decline patches dialog, you can decline in a broader way. You can decline whole applications, computer families, and such. All right, and that's about the missing patches. When you have a lot of missing patches, yeah, I have only 56. That's not a lot, okay. But if you have hundreds or whatever, then you can establish filters. Just build your filters here, name the filter, and then build your filters based on operating system severity and whatever. Let's say operating system equal to Windows one Windows version, and then add the severity as equal critical important, and save and apply that filter. Just give it a name, Win critical. Save and apply. And now it is filtered. Getting back into the missing dialog, just choose your filter and you have it filtered. Now let's have a look into the deployment section when we want to have it automated. I already have a automate patch deployment built up for one system, and you can see if it is green is completed, red would be an failure, and yellow would be missing, still missing. In case there is a error, a failure, you have within the detailed view, you will have the mistakes, the error, failed patches, and in case there is a failure, you will have a troubleshoot as well. The troubleshoot will cover every mistake, every error with a KB article and more details. So then let's build a deployment, an automatic patch deployment together. Let's just name it all updates. That's just a name I'm providing right now, and I will provide every patch in there, even optional updates, and in the third-party section, everything as well. Whatever you want to choose, you then can filter based on specific applications, patch even only everything except one application or more applications. Third party the same. Antivirus updates, driver updates, BIOS updates, all could be done automatically. Here you can deploy the patches after a specific amount of days after release or after approval. Let's go next, and then let's have the deployment policy. Anytime at the earliest would be all days, all weeks, 24/7. And the next, we choose the target. In my case, I will choose just a computer, just one of my laptops. And next, if you want to have notifications, if you're lonely and you want to have lots of emails, you can send yourself or a colleague of yours an email, and this every hour. Fine, let's save that. And now we have it here, all updates and immediately. Now I'll suspend that task for a second, and I'll go and approve all the other missing patches for that system. That's easy. Let's just go systems, and by patches, let's go to that system with the 25 missing patches in here, and I'll just select everything in that testing purpose now, and I'll get it approved. Fine. So now I'll go back deployment and get my automatic patch deployment running again, resume task, and then let's see, hopefully there will be some mistakes, some errors, then I can show you the troubleshoot as well. In the meanwhile, what else can we do? We can't even only automatically patch the systems. Of course, we need some kind of test and approve scenario. This is possible through the test and approve section. You can add here pilot groups for patching. This is a custom group. Choose whatever you want to have installed automatically on your test systems, in the Microsoft area, in the third-party area, exceptions as we've seen it before, driver updates, BIOS updates, deployment settings. If you want to postpone or having those patches from vendor release, let's deploy it only 5 days after vendor release or something like that. You can do that. Apply deployment policy, again, critical and important updates, whatever you've configured on your own, or choose one of the ready ones. and in the last step automatically approve tested patches after a certain amount of days, by meaning if a patch has been installed successfully on the machines within the test environment, all that patches after 3 days will be automatically approved. You do not need to do that manually, what we've been doing prior, that green flagging. If one of the patches fails to be installed successfully, technically successfully, then that patch will never be automatically approved. I'll cancel that. I already have a pilot group. All right, so now we have seen how to manually deploy a patch. We've seen how to create an automatic patch deployment and how to create a test and approve. You always are able, within automatic patch deployment, let's say, to duplicate your automatisms. So in that case, you could start with a basic critical important patches clients and medium and lower patches clients on different days, whatever, and then duplicate that to cover different locations, remote offices. So then you could have assigned specific technicians only to cover that remote offices on their own. Especially in large environments, it might come in handy when you do not have 1,000 systems within one deployment policy. Now, let's go back to that dashboard, to that new dashboard from threats and patches. There are now trends showing how our environment is going further down the road. We have here some recommendations. We have risk prioritizations by threat exposure. Everything of that is already linked. Okay, so you see everything in detail and filtered, let's say, and that can be also be configured in or set into a classes and types. All right, what else do we have? We could patch right from here, but how to evaluate what is the most critical thing? Not always the critical is always the one I have to take care first. Of course, every critical patch and every important patch, and in fact every patch, every missing patch has to be patched. But even in my environment, I have a bunch of risks and vulnerabilities, and those have to be addressed maybe in the right manner. And sometimes I have solutions, I might have solutions, software on my systems, what cannot be patched at all because other software, depending on it, is not ready yet for new updates. So let's go back to the dashboard again. We have vulnerabilities over time, vulnerability age matrix, and emergency risk catalog. And a lot of, advisories, risk indicators, EPSS scores, CVSS scores 3, and there should be the 4 somewhere as well, but this will be shown in the dialog here within threats. Now let's cover some basics, some of the theory I've talked about. We have here within the missing patches, we've had already in front those colors. These are the severity indicators. The red is critical, important, we have moderate, and something like that. And for Microsoft patches, Endpoint Central explicitly uses the Microsoft severity model. ManageEngine describes critical, important, and moderate low according to Microsoft's rating. And depending on the product, the rating may come from, for the other patches, for example, Apple, Red Hat, Adobe, Google, Mozilla, whatever. So this is taken from the respective vendors. And this information is then imported into the central patch database, is validated, and then published with the patch metadata into the central patch repository. The vulnerability database is synced daily automatically once, and you always can update it manually. Now, just by clicking here, it'll start the update progress. After updating the vulnerability database, automatically every client, every agent will get scanned. When we go back to the vulnerabilities, we can see also the CVSS scores. And the severity of a CVE is typically mapped into categories like 9 to 10 for critical, 7 to 8.9 high, or in parts of the ManageEngine interface important, and something like that. And the point to watch out is Microsoft uses important, CVSS typically uses high. ManageEngine may align terminology in different views or map it to the 4 categories: critical, important, moderate, and low. As a result, the same vulnerability may have a CVSS severity of high, while the associated Microsoft patch is displayed as important. So, and this is explicitly listing a severity and CVSS as some of several prioritization parameters. And because it is always difficult to indicate what is more important than the other important patch, ManageEngine has introduced its own risk score from 0 to 10. That's in here, risk score. It's an AI-powered dynamic score derived from real-time exploit activity, severity, exposure, and threat intelligence signals. And ManageEngine explicitly identifies these factors as the basis of the risk score. So, by meaning that 2 CVEs with a CVSS score of 9.8 can be prioritized very differently. CVE A, let's say, has a 9.8, and the real-world situation is no exploit, internal system, low prevalence. And the ManageEngine priority would then be potentially lower risk score. And another CVE, 9.8, might be active attacks, CISA key, ransomware association, many affected devices. And then the ManageEngine priority, of course, will be very high risk score. And a 7.5 CVE might be, in the real-world situation, active exploit on internet-facing systems. And then the risk for the ManageEngine priority would be possibly higher priority than the others with 9.8, where is no or potentially lower risk score, no exploits or something like that. So, to get it in other words, CVSS assesses the technical severity, by the ManageEngine risk score assesses the actual remediation priority. And then we have those fancy icons here, risk indicators. Highlights if the vulnerability is publicly exploitable, actively exploited, 0-day, linked to threat actors, or associated with malware. So these indicators do not necessarily change the vendor severity. However, They provide the information needed to treat a vulnerability rated only important from a technical perspective as an immediate priority. And then there is another assessment of the affected environment. ManageEngine additionally considers or visualizes the context of the organization's own infrastructure, and that's a few thousand clients, affected systems, number of vulnerable endpoints, operating system, software product and version, affected servers or clients, time of first detection. And that's the time of the first detection, first discovered here. And even more informations can be dived into. When we just click on it, we have advisory details, in this case, cert Sante, VDA cert, and all of those are referenced, with more informations. And the timetable of the vulnerability. Well, that's pretty cool. Vulnerability details were officially published to the public. Then in 24 and 26, ManageEngine introduced detection support for this vulnerability, and then first discovered vulnerability, first dedicated in your managed environment. We have here as well the detected CVE section on its own, and even here affected systems, and of every CVE we have more informations, and as you could see, we could deploy that patch as well. Zero-day vulnerabilities, of course, shown here as well, gathered here together, affected systems, and if there is a fix, we can fix it over here. Exploit status is shown as well. System misconfigurations is something else really serious. We can have that filtered as well, so we can go through every criticality based on the informations, and you will have more informations like descriptions and the caution. The fix is unlikely to cause any post-deployment issues in your network or something. There are always advisories, and you can deploy those secure configurations out from here already. High-risk software. That's something else. Do you know, out of the box, end-of-life software, what's already expired on what systems and what's gonna expire next? Peer-to-peer and remote desktop sharing would be shown as well. Web server misconfigurations is an informational and help offer here. It is nothing you can configure. It is just something, you see that here, you see the criticality, and you see a resolution, what has to be done in order to change that. A port audit is important as well. What ports are open and why. And I have prepared a kind of a table. What would show the patch severity versus the vulnerability risk. Let's make that a bit bigger. There it is. So there is the assessment type, like patch severity. The source software is the software vendor. We've talked about it, and the SSS is criticality of the published patch. And is it customizable? No, it is generally adopted, so it is coming from the vendors. The CVSS scores. The source is CVE NVD vendor or threat intelligence, and assesses technical impact and exploitability. Customizable? No. EPSS score. First EPSS, probability of real-world exploitation, customizable, no. Risk indicators is the source CISA, CERT, exploit, and threat intelligence sources, and the SSS is a real-world threat situation. Customizable, no. ManageEngine risk score. ManageEngine AI ML model combined real-world priority from 0 to 10, and the calculation is not freely configurable, as we can't change everything, all those severities, that assessment types. That's what I want to say, and from where it is coming. So affected systems prevalence, the organization's own endpoint environment, extent of internal exposure, and the changes are dynamically. Vulnerability age, the source is publication and detection data. The age and duration of exposure, no customizability. Patch availability, vendor ManageEngine patch repository. Possibility of direct remediation, customizable, no. System health policy, customer configuration, overall endpoint status based on missing patches, customizable, yes. We will show. I will show that where the system health policy can be customized. Quarantine compliance, customer configuration. May a system continue to access the network? Of course, it is customizable. I'll show that as well. Patch reliability score, ManageEngine deployment, telemetry, and internet intelligence. This is observed patch dependability and deployment. Deployment confidence, and the customizability is no. It is a dynamic score intended as an additional decision factor. All right, let's close my short overview, my table. And now let's see where that system health policy could be changed. That's here within the settings. We have the system health policy, and there you can define that maybe a system for yourself is critical only if there are 2, 3, or 23 more or more critical patches missing on that system. Of course, that's not advisable, and I strongly recommend leaving it in that strict manner. As well, if you want, you could exclude third-party patches to determine the system health and add exceptions, but this is what I call in German the lying into your pocket, because just because you don't see that the third-party patches are missing does not necessarily mean that you're safe out there. Okay, so all those can be configured, of course, but as mentioned, be careful with that. Now, what's about the other thing I talked about within my table? This is the compliance. Quarantine compliance, but prior going to the quarantine compliance, I'll show you another important part within here, helping you harden your systems. There are policy templates already available. That's an amount of 374 policies already for yourself to use. UK Cyber Essentials, NIST, SIS, STIC, whatever. And you can create your own Windows or Linux custom rules based on your requirements. Create custom rules or import rules to suit your needs. And when you have those templates, you can create audits. That's easily done by group. Taking a custom group into as a target, and then map your policies, and even a frequency, a schedule can be set up. When you have one of those set up already, I've just done one of these templates. I've let's take that one to see what's going on here. So you might have some auditors knocking after a while regularly every year every 2 years onto your doors. They want to see how secure is your environment, and you have your assessments already then. A 17% compliance is nothing good, but you want to go yellow or green. So then to show it to the auditor. So and to be safer in your company, of course. And here you see every one of those within the breakdown of these table content. And yeah, with the status, passed, failed, and such. You can filter them on failed only and then export them. Or you want to know how to fix it and why is it failed, what's behind that. There, just click on it. You will have a summary, you will have a rationale, a how to fix, and a reason. So there is a lot of help here and information. And then there is that system quarantine time policy. So if your systems, this is published on groups, on computer groups, and you can define conditions. Let's say vulnerability, exploit availability, exploit available. Plus maybe a vulnerability CVSS score above 8. Whatever, you can have a lot of different configurations set up and then perform an action. Send that systems to quarantine, block all network access, only internet in range, whatever. Set a grace period, set a notification, and then the system won't, it will be blocked to the network. The only communication will be between the agent and the central server, so that it is possible to patch that systems. After patching, after they are not within that rules, that conditions, they will be automatically released from quarantine. Now, that's about the threats and patches, the vulnerability management within Endpoint Central or within the standalone edition Vulnerability Manager Plus. Just some summarizing words from myself. So ManageEngine adopts the basic patch severity, critical, important, moderate, and low from vendor information. This severity primarily describes the technical criticality of the respective update. For vulnerabilities, Endpoint Central and Vulnerability Manager Plus supplement this classification with CVSS, EPSS, exploit availability, active exploitation, CISA, CAF data, threat actor, and malware associations, vulnerability age, patch availability, and the number of affected endpoints. From this information onwards, ManageEngine generates its own AI/ML-based risk score from 0 to 10. In addition, customers can use the system health policy to define the number of missing patches at which an endpoint is classified as healthy, vulnerable, or highly vulnerable. That would be then shown even here, in the dashboards. A newly announced patch reliability score adds a separate deployment confidence signal based on real-world deployment telemetry and internet intelligence. The key point for an evaluation is therefore, ManageEngine does not arbitrarily change a vendor's patch classification. Instead, it adds its own dynamic risk prioritization layer, and that takes the real-world threat situation and the organization's own environment into account. That's it for today's tutorial about vulnerability management or threats and patches. And hopefully I could show you that end of life of Windows Update services is not a problem at all when you have ManageEngine on your side. See you soon on my next tutorials.